A typical reverberatory furnace for melting solid aluminium is fired with natural gas. All aluminium scrap fed to a furnace has a very thin skin of aluminium oxide. When the scrap is heated in a furnace, the higher temperatures cause the skin to grow more rapidly, especially if the scrap is heated in air or an oxidizing environment. When the aluminum melts, the aluminium oxide floats to the surface, forming a second phase known as dross. Because of the surface tension of the skin, metallic aluminium is also trapped in the dross, from 15 to 80%. Large heavy-section melt stocks have the largest ratio of mass to surface area and sustain minimal melt loss. In-house remelting of clean scrap will increase the melt loss because of the increased surface area. For every 1% organics and moisture, 2% melt loss will result. Charging turnings, borings, and machining chips results in as much as 10 to 15% dross formation. An important factor is the holding temperature of the melt. The impact of temperature increases of only 25 to 55 degrees Celsius can be quite significant. The thickness of the layer of dross over the melt gives the insulating effect and requires increase in firing rate of the burner system. So, the thickness of dross on melter surfaces is most commonly maintained at less than 40 millimeters. Correct application of the proper flux composition results in the physical breaking of a weakly bound oxide layer entrapping fresh aluminum. This allows the metallic liquid aluminium alloy droplets to coalesce and return to the main bath. Metal-rich dross appears bright and shiny, certainly laden with metallic aluminium, whereas treated dross will appear duller and powdery. The aluminium content of untreated dross averages 85 to 90%. Furnace treatment can recover approximately half of this amount. In-house or outside dross processing can give the reduced metallic content in treated dross to 25%. The best way to initially deal with dross formation is to minimize it. This can be accomplished by a number of common sense and conscientious maintenance procedures. Use clean, dry charge materials. Use charge materials with high mass-to-surface area ratios. Use fluxes to cover the melt and reduce oxidation. Minimize melt cycles by stirring and pumping. Keep furnaces covered as much as possible. Keep burner flames from direct impingement on the molten metal. Ensure proper fuel-air ratios in burners to minimize oxidizing conditions. Hold molten alloy at as low a temperature as possible. Minimize turbulence or cascading during metal transfers. Employ the use of a dross reclamation system. Coat tools with an appropriate non-wetting wash. Keep furnace doors in good condition. Maintain positive pressure in melting furnaces. Ensure that thermocouples are in good working order. Thanks for watching. Remember to like, comment, and subscribe.